Okay, I'm back. All right, welcome to PLAR Science and also welcome to WASA Distance Education Center. Just a reminder that students can still register for IL courses at any time. We're still on week 2, so today is Wednesday, November 19th, so you can still apply for IL courses at any time. Also, if you miss the application for the Radio Zoom, you can still apply. You can contact Mary if you're interested in applying for PLAR, or you can contact Michelle. Potential graduates, make sure to check in with your teacher or grad coach to make sure you're on track to finish all of your courses by the June deadline. Okay, we're up next here. Just a reminder that WASA will continue to do end of term draws for students who submit work during each term. So we're now on term 1B, so make sure you're submitting work. Your name will go into the draw, and if you earn a credit, your name will also go in there as well. For current junior PLAR students, if you haven't already, please tell us whether you're planning on working on the lessons or if you're planning on working on the culminating activity. If you let us know, then that way we can send the materials that you need to get you started. For former students, since some of you were with us last time with WASA, we've made some changes to PLAR, so you now have the option to skip the lessons and take the open book test instead. So if you're interested in doing that, make sure that you let us know. Also, when you're in junior PLAR, in order for you to earn the equivalent credits, you need to complete all the required subjects. So if you have 0 credits from grades 9, 10, then you must complete all of the subjects to earn the 16 equivalent grade 9, 10 credits. Some of you may only be missing 3 grade 9, 10 credits, so you may only need to complete 1 subject. So here's how it works. These are the subjects for PLAR. So there's PLAR English, PLAR Math, PLAR History, PLAR Geography, and PLAR Science. Again, you may not need all of them. If you have 0 credits from grades 9, 10, then you will have to do all these subjects. Okay, some of our students may only be needing to do the math or the geography or the science. So it's important that when you're applying, if you have it, you can submit the Ontario student transcript that you have received from the last school that you have attended. So for students who need PLAR Science and you have chosen to complete the lessons, make sure you have all 5 lessons. So you can see here you have astronomy, biology, chemistry, physics, and environmental science. If you have previous versions of these lessons, meaning if you had one from, if you received the package from last year and you started working on the key questions, make sure that you still send the ones from last year. Okay, do not throw it out or don't say, well, I didn't have the new one. I will still accept the submitted work. Okay, you don't have to start all over again. As I said, I will accept the submitted work from the previous versions of the lessons. If you choose to do the culminating activity, when you do receive it, please read the instructions carefully. Okay, on the very first page, there's a set of instructions, so make sure you read it carefully. You can ask the DEC to print a hard copy for you. If you don't have a DEC, there might be someone else in the community that can print a hard copy for you. Oftentimes it's the school or the band office, or if you're not sure, you can ask me and we'll find out who may be able to get you a hard copy. Otherwise, we can send it out by mail. Once you get the culminating, you can complete it at home and it doesn't require supervision. So that means You don't have to write it at the Learning Center. In the previous years, we had to have someone supervise it, but this time it is an open book, so you don't have to stick around at the Learning Center and do the culminating there. You can take it at home, and there is no time limit, meaning, you don't have to set 2 hours for you to write it. You take your time completing it. Don't hold on it for too long. So, for example, don't have it for a whole month. Okay, you might need to uh, work on it. Maybe if you have a half an hour during the day that you can work on it, then you can do it that way. Okay, other ways for you to um, get support while you're working through your key questions or culminating activity, you can use our YouTube channel. It is a free channel, meaning you don't have to pay to watch it on YouTube. It's called WASA Distance Education Center. That's our channel. All the classes are there. So this term's 1B classes, that is being uploaded. And then last year's classes are also there. So it's organized in its own playlist for easy access to the lessons. If you're a potential grad and you're working on your literacy course, so the OLC 4.0, you can see that the course is there. So OLC 4.0, 2025-26, you can view the full playlist. If you don't have Wi-Fi or internet, we can give you an USB with all the classes. You just have to make sure your device has a USB port, so everything's organized by subject, then lessons with the key questions included. So this is all for PLAR, so PLAR Science, PLAR Math, PLAR History, English. It's organized that way. So if you need it, if you don't have internet or Wi-Fi, we can upload the classes for you. Once you're ready to submit your work for marking, lots of ways to do it. You can use your iPhone Notes app. You can scan each page of your work. If you don't like scanning or you're not sure, you can take a picture. Just remember that when you're taking a picture, try to take a clear picture of your work. So before you send it, just review it or preview it to see if you can read it. If you can't read it, then more likely we won't be able to either. Okay, you can also email your work. You can attach your scanned document, or if you've taken a picture, you can attach that to an email. You can send it directly to studentwork@nnec.on.ca. Make sure that you CC it to the teacher that's marking your work. So if it's for history, geography, and science, make sure you CC it to me. If it's for math and English, make sure you CC it to Bonnie. You can also share it through Google Docs. So if you open your assignment in Google Docs, click on the share button. It's probably different if you're using your phone to do it. With your phone, it'll show a picture of a person, and there's a plus button. Okay, that's the share button. For the setting, it doesn't matter if it's on editor or viewer. As long as you put in our email, we will be able to see it. Editor just means that we will be able to put comments on it. Viewer just means that we will be able to see it. So in either case, we will be able to print it. You can also ask your DEC to scan, or they can fax it for you. If you're in Sioux Lookout, it's possible for you. You can drop it off at 74 Front Street. We're next to the post office. We also have a WASA outdoor mailbox on the side entrance. Just make sure that you put your name on your work so that we know who it came from. And of course, if you have other concerns or questions, please do not hesitate to contact me, or you can contact the office. Now, if you're working on other PLAR subjects, for example, like PLAR English, History, or Geography from last term, instead of working on the PLAR Science, okay, start with the one that you have the most progress on. So for example, if you already have work done for the history or the geography from last term, make sure to finish that first before you join or start working on the PLAR science. Because if you switch between several subjects, you may end up not completing any of them at all. So try to focus on the one that you have the most work on. And again, if you're needing any help, let us know. Okay, so from our last class, we got as far as key question 35. Sorry, key question 20. It's worth 35 marks. I mixed those two up. Okay, so key question 20 was our last one. We only have a few more key questions left, 21 to 26. And then we're finished with lesson 1 here. Okay, so let's see how many we can do. Let's see which lessons or topics we have left. We have space exploration beginning on page 37. Page 38, what are satellites and space probes? Page 40, human space exploration and the space shuttle. Page 42 is about the space shuttle program and the International Space Station. Page 43, how do humans survive in space? And the very last topic we have is future exploration. Okay, let's do a quick review. So on Monday's class, we learned about the moon and how it moves around Earth. We found out that the moon always shows the same side to Earth because it spins on its axis at the same speed it travels around Earth. And again, you can try this particular activity on page 33 to see how it works. So on page 33, it shows you the phases of the moon, where you can try out the activity where you put a chair in the middle of the room, you face the front of your body to the chair, and you slowly walk around the chair. And as you're walking, what you will do then is you keep the front of your body facing the chair. Now you will notice that when you do that, what you have to do to your body so that it always faces the chair is you have to keep turning your body so that it always faces the chair, meaning you have to rotate your body. So if you're thinking about the moon, what does it do? Well, the same side always faces Earth. So what the moon does is it rotates. So you can see it on the bottom corner of the slide here. You can see the sun to the far left. There's the Earth. So the Earth is rotating. And then you can see the moon is also rotating. And it shows you what we actually see. So there is a side of the moon that we can't see, and there's the side of the moon that we can see. We also talked about gravity. And gravity is what keeps the moon in orbit around Earth. We also learned about the phases of the moon, or the stages. We talked about new moon, crescent, quarter, and full moon, and how the moon's position changes what we see from Earth. So it helped us understand how the moon moves and why it looks the way it does in the sky. Okay, if you're following along, turn to page 36, and we have space exploration. So we talked about scientists studying about space, but they don't just study space. They also send objects and people into space. In 1957, the Soviet Union launched the first artificial satellite. And that satellite's name is Sputnik. So it was launched into orbit. Since then, the United States, the Soviet Union, and other countries have launched satellites and people into space. So, what are some reasons for putting satellites and astronauts into orbit around Earth? Well, first of all, a satellite is an object that orbits another object in space. Now, we already know that the moon is a satellite of Earth. Now, the moon is a natural satellite, okay? It's not man made. So, when we talk about satellites being launched, these are artificial, meaning they are man made satellites. Let's look at the different satellites. There are four main types, and each satellite is specific to doing a certain job. So the first one is an Earth sensing satellite. Now, these satellites have cameras or sensors that face down toward Earth. As they orbit, what they're doing is they're collecting information about different places, even hard to reach areas like mountain tops. Earth sensing satellites are also used by some countries' military to observe other countries. You can see a picture on the right there. That's what an Earth sensing satellite looks like. The next one is space sensing satellite. Now, Earth's atmosphere can block scientists from studying space. So to get around this, what they have to do is they have to have satellites that are placed above the atmosphere. These satellites can clearly see space without interference from the atmosphere. An example of that is the Hubble telescope. The Hubble telescope orbits the Earth and is positioned above the atmosphere, and it can take pictures in space and sends them to Earth so we can see the universe. Okay, the third type is communication satellite. Radio signals can't travel through the ground, and the shape of the Earth blocks signals sent over long distances. So instead, radio signals are sent to satellites in space, which then send the signals to other places on the Earth. Now, sometimes one satellite sends a signal to another, and it continues on its way. So this is how messages can travel around the world. So if you think of all the different satellites or communication satellites, like Starlink, okay, you can use it to be able to have internet, and then you can use it to send your text or messages. Project Score was the first communication satellite. And finally, we have navigation satellites. So satellites help ships, planes, and even cars find their location on Earth by sending signals that they can listen to. There are four major global systems for this, like the United States GPS and Russia's Global Navigation Satellite System, China's Beidou Navigation Satellite, and the European Union's Galileo. Okay, so those are the four types. Okay, those are satellites. Next up is what we call space probes. So when studying planets and other objects in the solar system, it's sometimes best to be there in person. However, sending people to other planets is very expensive and dangerous. So imagine if you're sending an astronaut, that means you have to have that astronaut be there for a long time. So being there a long time can be expensive because you have to pay them, so they are salaried. Instead, what scientists will do is they will send robots or space probes to explore these objects. So space probes can come in many shapes and sizes, and they can do different tasks. Most space probes have cameras so that they can take pictures of what they're studying. Since they are much closer to their targets than we are on Earth, they can capture much clearer images. That just means they can get closer to what they need to take pictures of. One famous probe is Voyager 1. that was launched in 1977. It is the farthest human-made object from Earth. Now, it flew past Jupiter and Saturn and is now traveling toward the edge of our solar system. As of February 1st, 2010, it was 16.8 billion kilometers away from Earth. Now, some space probes are designed so that they can land on other planets and study their surfaces. Viking 1 and Viking 2, they landed on Mars in 1976 to explore the planet. Now, the most recent one that we've had was the Perseverance rover that NASA has launched. It landed on Mars in 2021. It's still there. It's still exploring and collecting rock samples. It recently discovered new things like a visible aurora on Mars. Now, aurora just means it's similar to the northern lights on Earth. Okay, so this way we're getting to know more about certain planets. Okay, if you turn to page page 37, okay, you will see that there's a brief history of space flight. So I will get you to look at that on your own. It just tells you what has been launched beginning October 4th, 1957. We said that Sputnik was launched into space. That was the first satellite. Then November 3rd, Sputnik 2 was launched with a dog named Laika on board. However, Laika did not survive the voyage. Then August 19th, 1960, we have Sputnik 5 was launched again. They carried the dogs Strelka and Belka, and they became the first living beings to survive a trip into space. On the 12th of April 1961, we had Russian cosmonaut Yuri Gagarin became the first human in space. Then July of 1969, Neil Armstrong and Buzz Aldrin became the first men on the moon. So it goes on right up to, I think we only did as far as January 2020, where we have SpaceX became the first commercial operator to successfully launch a crewed mission to the International Space Station with Crew Dragon Demo 2, and again, whose name varies depending on the organization. Okay, next we're looking at human space exploration. So we explore space because humans have always been curious about the sky and what lies beyond it. When we explore space, it helps us answer big questions like where we fit in the universe and how our solar system was formed. It also helps us develop new technology and carry out experiments that teach us more about science. Now, while we have probes and satellites giving us a lot of information, sending people into space allows us to learn even more, okay, including more about ourselves. Okay, let's look at space shuttles. Okay, so first of all, what is a space shuttle? Well, a space shuttle is a spacecraft that can be used more than once. Before we had the space shuttle, no parts of a rocket could be reused after a launch. What happens is some of the parts would fall into the ocean, and then others would burn up when coming back to Earth. Even the capsules, so you can see on the right-hand side of the slide there, that is a spaceship, which is a more general term for any vehicle designed to travel into space. So the capsules that carried astronauts, just like the one there on the right-hand side, could only be used once and had to be replaced for every new mission. So you can imagine how expensive that was. So this way of exploring space was very expensive. So scientists knew that. So they wanted a more affordable way to send things into space. So they created what was known as a space shuttle. So with the space shuttle, it was designed to be used over and over again. So it's reusable. Only one part with its main fuel tank, that's the only part that must be replaced. So we have three main parts. We have the shuttle orbiter itself, and that has three main engines. There are two solid rocket boosters for the extra thrust, and then you have the external tank, which is a large fuel tank. So if you turn to page 40, you can see how it works here. Okay, I'm just going to put it on dual display so you can follow along. So as you can see, you get the blast off. So at launch, all the parts of the shuttle are connected. The main engines and rocket boosters fire, and then the shuttle lifts off and it heads into space. So here we get the launching. So pre-launch is right at the bottom there. So everything is ready, and then there's the launch. The booster separation. So after a few minutes, the rocket boosters run out of fuel. Then they will separate from the shuttle and use parachutes to fall back to Earth. So when they fall back, that's when they are recovered and reused. The main fuel tank stays attached and it continues to supply fuel to the engines. Then we have the fuel tank separating. So we're over here now. You can see that the external tank separates. It will separate when it reaches the right speed and position. Then it will detach. It burns up as it falls back into the atmosphere. Now that is the only part not reused. Whereas before, everything else you had to get rid of because you couldn't reuse any of them. So in this case, just the fuel tank is the only part that's not reused. Then the shuttle orbits around the Earth. So now it's completing its mission. It can stay in space for several days or longer until the crew completes what they have to do. Then it returns to Earth. So after the mission, the shuttle returns to the Earth. Now, since it doesn't have fuel to power its engines, it glides back like a glider. So when it lands, the shuttle lands on the runway using wheels. So there you see. And it lands just like an airplane, and then it is prepared again for its next mission and reused. Okay, let's take that off the dual. So again, you can read that on page 40. So the shuttle program, it had a total of 5 space shuttles and used for 135 missions from 1981 to 2011. So they were launched from the Kennedy Space Center in Florida. They were used for missions like building and repairing the International Space Station and doing scientific experiments. Sadly, 2 shuttles were lost in accidents, Challenger in 1986, Columbia in 2003. In total, 14 astronauts lost their lives. The program ended on July 21st, 2011, after the final flight of the Atlantis shuttle. Until NASA develops the Orion spacecraft, astronauts travel to the ISS on the Russian Soyuz spacecraft. So we talked about the International Space Station, a little bit more about it. It is a large spacecraft that orbits Earth. This is the biggest artificial satellite in space, and you can often see it from Earth without a telescope. It is made of parts like pressurized modules. This is where people can live. It has solar panels and other components. People from 17 countries, including astronauts and space tourists, have visited the ISS. So, what happens on there? Well, it is a science lab in space, and astronauts can do experiments in areas like biology, physics, and astronomy. These experiments, they help us learn how to keep astronauts safe, healthy, and productive while they're doing their space exploration. Scientists also study how things behave in space where there is no gravity. The ISS crew can help students on Earth by they run student-created experiments, they make educational videos and demonstrations, they let students try versions of ISS experiments in their classrooms, and they can talk to students through radio, video, and email. The ISS recently marked its 25th anniversary in space and continues to be a key place for important research. Scientists use the ISS to learn about how long-term space travel affects human health, and they've also tested new technologies that will be crucial for future missions, like trips to the moon and Mars. Okay, let's try out some key questions. So if you turn to page 53, key questions 21 and 22 are available on that page. Remember, when you're answering the questions, please use only the materials provided. I don't want you using the internet or Wi-Fi to search for answers. Send me the pages uh, that will have the key questions, so pages 49 to 53. You do not need to send in the whole lesson. Keep that so you can use that for a review. And as I mentioned before, all the information that you need to get a hold of me is on the cover pages the of the lessons. It gives you our phone number, so for WASA, whether it's the studio or the radio booth. We also have our office number there, the toll-free number, my extension, our fax number. You can see my email and Facebook is there. The link to our YouTube is there as well. And if you have friends or family that would want to sign up, the WASA registration link is on that cover. Okay, so we will do key question 21 and 22. Here we are. So key question 21, it says identify the following artificial satellites. Where you have a blank space, that's where I want you to write the name of the artificial satellite. So for example, blank, this satellite can pinpoint their location on the Earth by listening to the signals. Number 2, blank, so you see the blank there. Messages can be sent all the way around the world this way. So that one you probably know already, that type of satellite is called communication satellite. So now you would have to do the third one and the fourth one. The third one, these satellites have a clear view of what scientists want to study in space. And then finally, these satellites have cameras or some other kind of sensors pointed down at the Earth. Okay, so those are the 4 artificial satellites. You just need to put down in the blank the right name for the description. Key question 22. In 2 or 3 sentences, tell me more about the International Space Station. Okay, so just 2 or 3 sentences. Tell me more about it. Okay, let's continue on with our next topic. Okay, how do humans survive in space? So without water or food or air, space or shelter, we know what can happen to living things. They will obviously die. So everything around a living thing is its environment. So you're talking about air, water, temperature, air pressure, food. Okay, all of these. That's why there are people living on Earth, because Earth's environment is perfect for life. We have air to breathe, we have food to eat, we have water to drink. Now the air pressure is just right, and the temperature is usually not too hot or too cold, Just like we looked at all the different planets, we said some planets are 10 times hotter or colder during the day, or even more so than that. So you're looking at sometimes 400 degrees, which is very hot. So for Earth, the atmosphere also protects us from harmful radiation, and that's why Earth provides a safe and friendly place to live. So from what we know, space is not a safe place for humans. It has many challenges. You can't live in space like you do on Earth. There is no air to breathe or air pressure. The temperature, as I said, can be extremely hot, or could be the other way around, freezing cold. No food grows in space, and there is nothing to protect you from harmful radiation. There are also other challenges in space. Living things create waste, and it needs to be removed. On Earth, that's easy to do. When we breathe out, we release carbon dioxide. Heat and sweat leave our skin and go into the air. We use water to flush away liquid and solid waste. But in space, getting rid of waste is much harder. Even staying clean is a big challenge. Okay, so let's see what happens. If you're following along, you can turn to page 42 and 43. On Earth, gravity keeps you on the ground, but in a moving spacecraft, there is no gravity. Okay, that's one thing to keep in mind. Technically, gravity still pulls on the spacecraft, but its movement cancels it out, which creates what's called zero gravity. Now, in zero gravity, you feel weightless. So imagine you're floating around the spacecraft unless you hold onto something. Because living in space is so difficult, astronauts have to bring their own environment with them. This environment needs to be like Earth. Special suits and tools are made to give astronauts everything they need to survive. So you can see some pictures here of the astronauts on the International Space Station. They're preparing to share a meal. The quality of their menu is very different with those of the early space explorers, where meals were either semi-liquids and they were squeezed from a tube or bite-sized cubes. Okay, and these, you can see the pictures there. So when they're eating in space, like I said, everything is weightless, so eating a normal meal like on Earth isn't possible. Food would float around inside the spacecraft and astronauts would have to catch it. And as I said, early astronauts ate soft foods from tubes. They're very similar to toothpaste tubes, so what they would do is they would squeeze the food directly into their mouths. The space shuttle has a kitchen area called a galley where astronauts can prepare their meals. It even has an oven to heat pre-made food. Some of the food is dried out and all they have to do is add water to it before eating. Outside the spacecraft, astronauts don't always stay inside the spacecraft. Sometimes they have to go out on what's called spacewalks outside. During the spacewalk, they have to wear a special pressurized suit that keeps them safe. The suit will give them air to breathe, water to drink, even food if needed. They also have a rocket backpack called a jetpack, which lets them move around and fly in space on their own. The backpack has tiny thrusters that astronauts control to steer and stay close to the spacecraft. Spacewalks are used to fix equipment, or they may use it to perform experiments or explore their surroundings. Imagine if you are in space without a spacesuit. Several dangerous things can happen because space is a very harsh environment. First of all, you have no air to breathe, so there's no oxygen in space. You would lose consciousness within seconds and could not survive for more than a couple of minutes. We've talked about the extreme temperatures in space. It could be extremely cold in the shadow of the sun, below minus 157 Celsius, or very hot in direct sunlight, above 120 degrees Celsius. So again, your body would not be able to handle these temperatures. No air pressure. Without air pressure, the gases and fluids in your body would expand. This wouldn't cause you to explode, but it would make you swell up, damaging your body. Radiation, so space is full of harmful radiation from the sun and other sources. And again, without protection, your body would be exposed to this radiation, which can cause severe harm. And boiling body fluids, so in the vacuum of space, your saliva and tears could boil because of the low pressure, even though the temperature is cold. So in short, or in summary, being in space without a suit is life-threatening, and survival would only last a few seconds. Okay, on the right of the slide there, we have Chris Hadfield. He's a Canadian astronaut. He's retired. He was born in Sarnia. He was a test pilot. The time he spent in space, 166 days. So we talked about weightlessness in space. So astronauts experience weightlessness. That means they feel like they are floating all the time. There isn't much they can do to stop this, so they train to get used to that feeling before their mission. So in preparation, astronauts practice in special airplanes called vomit comets. And what happens is these planes fly in a way that creates moments of zero gravity, so astronauts can experience what it's like to float. They also train underwater, and when they're training underwater, it simulates weightlessness because the water supports their body, makes them feel lighter. So again, practicing these helps astronauts learn how to move, work, and handle tools in space where everything floats. Future exploration, which is our last topic. Many scientists believe that sending humans to Mars is the next big goal for space exploration, and it could even lead to building a permanent colony there. The European Space Agency plans to send humans to Mars between 2030 and 2035. NASA also announced back in 2007 that they aim to send someone to Mars by 2037. Robotic missions and scientific studies have shown that Mars has some features that's very similar to Earth, like evidence of water in the past and a rocky surface. However, Mars is also very different, and there's still a lot we don't fully understand about the planet. But a mission to Mars would not only help us learn more about the planet, but also test whether humans can live far away from Earth for a long time, or even permanently. Okay, so let's look at the last key questions we have. So these are on pages, it's only on page 53. And engineers and scientists are working hard to build the tools and technology that astronauts will need to live and work on Mars so that they come back to Earth safely. Also, NASA is also working with other countries and U.S. companies on a big plan called the Global Exploration Roadmap. And again, their main goal is to send people to Mars and help humans explore more of space. Okay, let's go to page 53. Now, some of the questions here are opinion questions. That means it's asking what you think. Okay, question 23. What are 2 ways astronauts can prepare for the feeling of weightlessness? We just talked about that. How do they train on Earth so that when they get to space, then they know what to expect? This one, key question 24. Some people believe that society should build places for people to live in space. Now, this question says, why might people want society to do this? Why do you think they might want to build places for people to live in space? You may think about, well, what if the Earth becomes overpopulated? Maybe there might be a place that we need to be able to go. Why is it cheaper to send space probes to other planets instead of sending astronauts? So again, the word here is, keyword here is cheaper. So why is it cheaper if you send artificial satellites or space probes to other planets instead of sending people, okay, or astronauts? And 26, that's your final key question. In your opinion, so again, it's what you think. So that means you don't search on the internet. You don't Google human exploration of Mars a good idea. I want your opinion, not someone else's. Do you think that exploring Mars is a good idea? So why or why not? So you might start off with, yes, I think this is a good idea. And then you tell me why you think that is a good idea. Or, so again, choose either yes or no, or it's a good idea, or no, not a good idea. You might say, no, I don't think it's a good idea, and you tell me why. Okay, so that is the end of lesson 1. That means that we have completed. So what you can do is you can go to the page where it tells you the list of the key questions. There are 26. So if you have finished that, then you can go on to lesson 2, which we'll be doing next week. Now, the other thing that I'd like to mention, when you are looking at your key questions, and I notice I don't, oh, there it is. So you finish up to key question 26, and you send me your key questions, you get a good mark, and now you're feeling that, hey, maybe I want to try the culminating activity. You still have that option. Okay, so it doesn't matter whether you finish 5 key questions or 40 key questions, you have the option of asking for the culminating activity. Okay, that's it for today. Thank you for joining me. Miigwech.